So our environmental control system, you can see various components that, make it up. We have packs, which provide heating and cooling. We have filtration for our, for what's called recirculation. Any air that's moving around the cabin going to be moved around, we use that. And then circulation itself, because we need to have air moving to the cabin, to the cockpit, into the avionics bays, into the cargo compartments. Cargo compartments, because you don't want everything to freeze in your luggage. Cargo compartments, because we carry live animals or other things that, would need to be kept warm and need to be kept, have fresh air, or at least stale fresh air by the time it gets to the cargo compartment. But here's a general kind of description of what we have, with a twin engine aircraft, for example. You can kind of see there's kind of a left and a right half of the manifold, but you can combine them. We have an APU or ground cart. And then that feeds into some distribution manifolds that can send air up to the various parts of the cabin. This aircraft does have a ram air opening as well. Most aircraft have that, or a lot of aircraft have that, where you can open that valve as the plane's moving forward. It's used for if you have a situation where you get smoke or chemical contamination in the air system, you can open that ram air valve to force fresh air through the cabin, but you're going to lose pressure, a certain amount of pressurization. We look at it in a little more detail, you get something that looks like this. So here we have, I've cut off the engines. The engines are here. Flow control valve, air from the engine, from the left engine, the right engine roughly is coming in here. Actually, it's coming in from the manifold that makes up the engines and the manifold. And then air goes through some packs, left and right pack. And then you can see it flows into like mixing ducts and manifold, and some goes to the flight deck, different parts of the cabin. And you got to look at it from different ways, because some air goes to the top and comes down through the gaspers and vents around the overhead bins. Other stuff comes up from the floor to warm people's feet. Then air can flow down into cargo compartments, underfloor. And then ultimately it's going to flow out through the outflow valve. Oh, forward bay, we've got air being directed to the forward electrical and equipment bay, right, to provide avionics cooling. If we look at the pack a little bit closer, it looks something like this. So enlarging that area there. A pack is used to get that temperate air that we're gonna run through the aircraft. We'll look at those in detail in a second. But this whole system, the packs, the distribution, we want to have comfortable air in the cabin, has to take variable temperature air. So here's an example of an aircraft during climb. The bleed air might be somewhere between 500 and 600 degrees, right? Because the engine's working really hard. At cruise, you can see it's dependent on altitude, because you're going to get a certain amount of temperature rise. And so, the higher you go in altitude, it'll cool off the air a little bit more, because you're bringing cold air in, and it's not getting compressed. You're not getting the same compression. And then during descent, when we throttle the engine way back, you can see the compressor isn't heating it up nearly as much as before. And so this whole system, these packs and everything else, has to be able to take this 300 and we'll say 20 degree air to 550 degree air and turn it into 75, 70 degree air, 68 degree air, comfortable for people and animals. The other thing we have is we're going to have variable pressure. Many of you have seen this now in engines. I've drawn this diagram for several of you. And the question I ask is, why are there two pressure ports on the engine? 10th and, no, 6th, 8th. What are the two pressure ports on the JT9 that I have you look at? 8th and 15th stage. Okay, different engines is different. One airplane I worked on was 6th and 10th stage. The JT9 is 8th and 15th stage compressor. So, but most of the time you pull from two different ports on the engine. Another one that I worked on was like 6th and 14th stage, something like that. So we have a high pressure source. We pull from further back through the 15th stage of the compressor. We have a low pressure source, say the 8th stage of the compressor. And the reason we need a pull from 2 is because, so here, this example, this aircraft's looking for 45 PSI in the pneumatic manifold. But when, the engine is ground to flight idle, anything below this is effectively 0. You can see even the high pressure is a little bit below that. So it's gonna, we're gonna try to get to that 45 PSI. And as we get a little bit above flight idle, right, takeoff's essentially 100%. We get above flight idle, you can see we can regulate the high pressure down with the high pressure shutoff valve regulating and pressure regulating shutoff valve. Okay. And so pressure, and then you get to a point where now the low pressure side, say the 8th stage, starts to make enough pressure. It can provide that pressure to the aircraft. So now the high pressure shutoff valve begins to close, and now we just regulate it with the pressure regulating shutoff valve to keep that 45 PSI. And so, between as the RPM or the engine thrust level increases, okay? Because we don't want to overpressurize it. We don't want to have to regulate as much. The other thing you're going to get, remember with these two different things, is the low pressure is going to be lower temperature than the high pressure. So also, while the high pressure side pressure is increasing, there's a point where the temperature will be too high as well. And so we don't, it may be at this point, say to, 2/3 of the way over, low pressure might be at 300 degrees and the high pressure might be at 500 degrees, right? And so at that point, it's easier to cool. We don't need 500-degree air to heat the cabin. We don't need 500-degree air to heat the wings. 300-degree air is more than sufficient and takes less effort to cool back down to 70-degree air and has less risk of damaging things. So all of these are going to feed into, for environmental control, our packs. And a pack is made up of a few parts. At its simplest form, it has an air cycle machine, which is a compressor and a turbine that are hooked to each other. In some cases, they're two separate wheels that are attached with a shaft. In some cases, they're one solid piece that are like back to back. Okay? The turbine drives the compressor. We have heat exchangers, typically 2 or more, oftentimes 3. You would include if you have a pre-cooler, that's another heat exchanger. So most packs have 2 heat exchangers in the pack itself with a 3rd pre-cooler on the engine or in the pylon area. Those are cooled by either ram air in flight or forced fan air on the ground. So we have to, heat exchangers to move heat from a high heat area to a low heat area. So we're going to be taking heat from that high temperature bleed air. We need to move that heat into somewhere, and we need to exhaust it. We need to waste it somewhere, and we dump it overboard by pulling in outside air, cooling it, and dumping that air back overboard. And then the mixing system is, we don't want to put 300-degree air into the cabin, and we don't want to put 20-degree or 10-degree air into the cabin. And I'm talking Celsius right now with the 10, 20, maybe 32, 34-degree air into the cabin. So we need to mix hot and cold air together to get room temperature, comfortable air. Okay. And that's done through some kind of mixing valves, bypass valves, or mixing manifolds, or typically some combination of those items. And then to run it all, we have to have sensors. We have sensors throughout it that are going to measure things like pressure and temperature in different areas. And then finally, that's going to feed into our control. Our control is going to connect the valves that turn this on and off. They're going to connect the valves that mix this to the sensors that are going to provide input. So the sensors provide input to the control side. The control side then is going to adjust the mixing system, the on-off controls, all that kind of thing. One group in here got to feel how much heat comes out of the airplane, right? How many of you actually got to before the tube blew out? What was coming out of the bottom of the airplane when that thing ran for a couple minutes? It was pretty warm. And how much was coming out? Quite a pretty big room fan, yeah. Yeah, it puts a lot of heat out. So simplest form, this is probably the simplest pack that I've ever been able to find. So what we have here on the right, the red, is our air coming in, our hot air coming in from our pneumatic system. Air's come off the engine. There might be some kind of a crossbleed, whatever, but air from the engine, say 300-ish degrees. We go through, here's our heat exchangers. A right here to B is our outside cooling air. This is sucking air in from outside the airplane, or it's ram air being forced in. B is it's exhausting overboard. So hot bleed air comes into the heat exchanger. It gets cooled a little bit, but it's not cold. You can see it's still pretty red, but it's cooler. Then it goes into a compressor. That compressor is going to increase the pressure, but it's also going to heat it back up. But that heating it up, that compressing, that heating, that's adding energy to the air. That energy has to come from somewhere, right? So that energy is coming from our turbine. We'll get to that in a second. So the air cycle machine right here and the heat exchangers, all they're doing is moving energy around. This first heat exchanger, it's moving heat energy from the bleed air into the cold outside air. Then here we're moving heat energy and mechanical energy from further in the system back to the air earlier in the system. So it warms back up when it compresses it. Now we go through the secondary heat exchanger. That takes more of that energy away and exhausts it overboard. Then you can see it's still warm, but not cold, right? We bring that high, it's fairly high pressure because it just got compressed right here. Now it's higher pressure than when it came in. Now it goes through a turbine, it expands, the pressure goes down. That causes the temperature to drop significantly. This output air right here coming right off the turbine, if you're not controlling this carefully, can get into the negative numbers to the point where it starts to freeze up any moisture in there. And if that moisture builds up on your turbine, it can damage your cycle machine. So you never want it to go below freezing. But it goes in the turbine. Now we get maybe 34-degree Fahrenheit air coming out of that turbine. And that energy that took it from 3 to 4 right here, that energy was transferred through this shaft to drive the compressor. And in this version, it's also driving a ground cooling fan, a fan to help draw air through the heat exchangers when there isn't ram air, when the airplane's not flying. When it's flying, there's a ram scoop up here that's going to force air through, even more air than what it needs on the ground. And then because that air coming out of the turbine is going to be so cold, you can see we have a branch of not our hottest air, but some air that's cooled down a little bit, but still pretty warm, maybe a couple hundred degrees. We have a valve here that we can control what the ultimate temperature is coming out at 4 by adjusting how much air flows through 5 right here. That's our mixing valve. Okay. The other thing it does is as we open this valve, more air flows this way, less air flows through here. We're not going to get as much cold air coming out of here. It actually slows down the air cycle machine. So it does two things. It mixes more hot air in, and it'll reduce the amount of cold air we're getting out of that. Now, this is a very, very basic one. Most of them are a little bit more complicated than this, but this gives you some idea of how these work without adding a bunch of components. If we make it a little bit more complicated, you get something that looks like this. So here we've added a few more components. Bleed air is coming in. It still goes through, now it goes through a pre-cooler and a primary heat exchanger. So this is kind of our warm air in green. And you can see it comes up and there's a bypass valve, right? So this is where it goes back out to the cabin. Okay, we had one of those before, so that's not really any different. But then it goes through, it gets compressed to heat up. You can see there's an over temp shutdown switch here. It's warmed back up. It goes through that secondary heat exchanger. That didn't really change a whole lot. But as it cools down, kind of a neat thing here, as it cools down, what happens to moisture in cold air? It goes from being a vapor to what? A liquid. Liquid gets siphoned off and sprayed over the heat exchangers. It makes them work more efficiently. Actually, sorry, that's air being going there. The water comes from the water separator. So we use a little bit of air to run our aspirator. That's almost like a fuel nozzle. It uses air to shoot water over our heat exchangers. But that cool air, now it's cooled down. Here's one water separator. We want to get moisture out of it before it goes in the ACM so it doesn't freeze up the air cycle machine. Okay? And that one drains overboard. Now the air goes through here, it gets really cold, right? Because that energy is being used to drive the compressor. It's also, in this case, being used to drive a ground cooling fan. So now we have really cold air coming up. You also have some really hot air. So you have hot air here. You have like a medium temperature air here, and you have cold air here. So you've got like 3 different airs, cold, medium, hot, all mixing together here to get comfortable room temperature air. But then you're going to get water separating out. So you separate out some water here. That's the water used to spray out the aspirator to help increase the cooling capacity of the heat exchanger, right? Because we spray water on it and then it starts to evaporate and that pulls even more heat away. And then the discharge air goes out to the cabin. We never want our air going out to the cabin to be over 104 degrees Celsius. So there's a thing there. 104, remember 100 degrees Celsius is boiling. That's really hot. We really don't want super, super hot air. 210 degree Fahrenheit air going to the cabin. By the way, if you hear my melting duct story, that was the temp switch that was disabled and melted all the ductwork in the airplane. They got put into manual and set to full hot. And basically it was just routing hot air out straight into the cabin. Melted all the ductwork in the cabin. Had to pull the whole interior out and replace all the fiberglass ductwork in the cabin. That's what happens when cleaners think they know how to control the air conditioning on an airplane. Nope. Just another slap on the wrist with the 50 others that he had. But yeah, so air goes out the cabin. Now, in this case, we have ram air on the ground. There's a check valve here. Air gets sucked in. The fan driven by the turbine here is going to bring that overboard air, and then it's going to blow it out here. Or in flight, ram air can get through. There's a check valve that can force pass plus that as well. Okay. Here's another version. This one actually has a dual turbine. You'll see there are 2 turbines here. If it wasn't complicated enough already, we can add additional turbines or additional compressors. Okay. So heat comes in, primary heat exchangers, all that. I'm not going to go through every step, but you can see here it goes into, these have reheaters and condensers that can put warmth back in. Ultimately goes through a second expansion turbine out to the cabin after getting warm air mixed back into it here. So these valves, this is an example of that dual bypass valve. It's mixing cold, warm, and hot air together. You know, this air coming out is cold. It's too cold all the time, so you're either going to mix some warm air into it, or if you need it to be hot, you're going to mix some hot air into it. You can see the cold here isn't regulated at all, other than as these valves are more open, you get less cold air flow through the ACM. Okay. And here's an example where they're just mechanically linked together with a little motor to drive them. So these can be run in 2 different ways. We did this in the lab. You ran them in automatic, where you set a selected temperature, and the system, looking at those various sensors and everything, are going to adjust these valve positions to try to maintain a comfortable temperature. But they have a reversionary or manual mode that you can directly control that mixing valve or bypass valve by just changing its position. However, oftentimes that disables any or all safeties in the pack. Sometimes there's still a safety that does, all it can do is shut off that main valve, the main shut-off valve that sends pressure into the pack. So it would be this valve right here. Okay. So you sometimes do still have that ability where if it's, things really get way too hot or way too cold, it'll just shut the pack down, but it doesn't have the ability to control it anymore when it's in manual. Okay, so kind of a safety, but not a big safety. We talked about air distribution earlier. This is kind of I wanted to show you just the 2 kind of diagrams. So if we look down the cabin, you can see majority of the air actually comes in, goes out the top. You have the gaspers and vents around the overhead bins through the cabin area, and then works its way down through vents, cabin exhaust outlets, through the floor into the conditioned air spaces underneath the floor. things like cargo holds and or avionics space. So typical airflow is from top to bottom. It also typically goes from front to back. So a lot of airflow up in the cockpit, some airflow back into the cabin, and then it's ultimately all going out through the outflow valves when we talk about pressurization at the rear. And the reason for that is if there is any kind of contamination, it can be quickly cleared from the most important part of the airplane, which is where the people sit that make it go, go flying through the air and not crashing into the ground, hopefully.